Hello class, and welcome back to another lesson here on Holbert Helps. Today's topic is the distributive property. To be more specific, I'm going to be teaching you guys how to do the distributive property using generic rectangles. If you got suggested this video and you were sent here from one of my later lessons, then I suggest you watch it all the way through, as the generic rectangle is a wonderful skill to have. And you'll be using it in later things such as factoring or multiplying polynomials. So, with that being said, to even talk about the distributive property and using the generic rectangle method, we need to go back to just the simple idea of finding the area of a rectangle. So if I have this rectangle here and it has a base of 3 and a height of 5, how do I find the area of it? That's my question. How do I find all of this on the inside? And the way that I find the area of a rectangle is I do base times the height. So I'm going to take the base, which in this case is 3, multiply that by the height, which is 5, and I get 15 as my answer. So that means that all this area on the inside here is equal to 15. So on the surface, it might seem like these two ideas, rectangle and the distributive property, are separate and they're not related at all, but that's not true. We can actually apply this to our distributive property. So what we're going to do is, first off, we're going to draw a rectangle. That is step one. You see a distributive property problem, draw a rectangle. Next, we need to find the base and the height of this rectangle. And we're going to assign the base and the height based off of our problem here. So the base of this, or let's do the height. We'll do the height. The height of this rectangle is going to be 3. Just 3. And then our base is going to be 2x minus 1. Now, I know when to move on to the bottom part, to move from the height to the base, once I see a new set of parentheses. So I started with a 3, I hit a new set of parentheses, I know to move on, and that this part becomes the base. Now, I'm not done. To finish setting this up, what I need to do is I need to check and see if there is any separate parts of my equation. So here we have just the 3. Since it's just the 3, we're good here. But here we have 2x minus 1, and this is what I'm talking about. There is an operation right here. And since we have this minus 1 here, we're actually going to draw a line in our rectangle where that minus sign is. Okay, now from here, we're going to follow base times height. So I'm going to take the base, which in this case is 2x, and I'm going to multiply it by the height of this rectangle. So 2x times 3 is 6x. And then I'm going to repeat that process. Go to my next little rectangle that I made in here, and I'm going to take the base, which in this case is -1, and multiply it by the height, which is 3. And I get -3. Now, when you get to this part, you're still not done. If you leave it in the rectangle, it kind of looks messy, and your teachers might not appreciate that. So you're going to take this and you're going to rewrite it on the outside, 6x minus 3, and there's your answer. You distributed this 3 through. Now, a couple of things that I would like you guys to keep in mind as we work through these problems. First off, first thing you do, draw that rectangle. Second, you're going to assign parts of your distribution to either the base or the height of the rectangle. I decided to put the 3 here, and then once I hit the new parentheses, I write that part as the base. Then there's one more thing I need you to notice, that I brought these signs down. So here I have a minus sign. I brought that minus with the 1 to the box. And the reason why is that it makes it easier to keep your work clean. I know that this is a -1, so if I multiply these two together, this has to be a -3. Please bring the signs with from your parentheses to your generic rectangle. Please bring them with. If you don't, you're going to make small mistakes. You're going to forget a negative. You're going to forget double negatives, something like that, and then you're going to get the wrong answer. So we can use this generic rectangle to distribute through. If you're still a little bit confused, I suggest you watch this next problem, as problem 2 is what a lot of you were probably thinking when you thought of the distributive property. This is probably what you were thinking of when you were thinking, hey, I need help with the distributive property. It's probably like this. So anytime you see a question that says rewrite the following product as a sum, what it's asking for is it's asking for you to do the distributive property and to write it out afterwards. We're going to solve this the exact same way we solved problem 1. And I showed problem 1 mostly to show you guys that this generic rectangle idea works for the simpler ones, but it also works for the complex ones. And that's what makes it so awesome, is that it is extremely, extremely flexible. Okay, so I drew my rectangle. That was step 1, remember? Now I'm going to write this first part as my base. So I'm going to do 3x, and then remember I'm going to write my sign, minus 3. Now I hit a new set of parentheses after that, so I know that this part is going to be my height, x minus 7. Now, in fact, here, I'm going to do this for you guys. I'm going to take this, I'm going to highlight it. This one was the height, and this one is the base. So keep that in mind. Now, once again, our next step is we look for these separations of our integers or our parts of the equation, and we're going to draw lines. So draw a line there, bam, and draw a line here, bam. And now if you look, I have 4 separate rectangles. And a good way to check that you have enough sections in your generic rectangle is, well, how many different sections do I have here? 1, 2, I have the 3x and the negative 3. So I should have 2 rectangles. And then I have the x and the minus 7. Those are 2 separate sections. So here I have 2 and 2, which is 4. So I have 4 parts. Now, we can do the same thing. We can multiply to start filling in these separate boxes. So here I have 3x times x, because base times height define the area of this rectangle. So 3x times x is 3x squared, okay? 3x times negative 7, watch those negative signs. 3x times negative 7 is negative 21x. Now if I come over here, negative 3, once again, watch those signs. Negative 3 times x is negative 3x. Negative 3 times negative 7 is positive 21. Okay. Now, as a reminder, we're not done here. We need to take all of this on the inside and rewrite it. So I'm going to take all of this and I'm going to rewrite it over here. We have 3x squared minus 21x minus 3x plus 21. Okay, so that was everything inside there rewritten over here. And now I'm going to combine like terms. So I'm going to combine negative 21x and negative 3x. So let's rewrite the rest of it. 3x squared minus, so negative 21x minus 3x is negative 24x. And then plus 21. Now there's no more terms for me to combine, no more like terms. So I'm actually done right here, okay? I finished. So I successfully rewrote this product as a sum. As a reminder, product means multiplication. I'm multiplying right here, so it's a product. And if we check here, we're adding, so it's a sum. Okay, 2 things before we move on to our third example problem that I would like you guys to keep in mind. First off, notice how I wrote the variables or the x's in this bottom left corner here. I made sure that the x's were close to one another. That is not required. However, I suggest that you do it. It makes your work a bit neater, and if you get into this habit, it'll help you later on down the line when you are doing things like factoring using this method. Once again, it is not required, but you'll be thankful for it later. Okay, then the other thing I would like to point out is when we come over to our final answer here. Notice that I took the 3x squared and I wrote it first. Whenever you're writing your sum, you should write your variable with the highest power first, followed by your next variable with the highest power, so on and so forth, and then the last thing you write should be your constant, or your number without a variable with it. This is not required, but it is the polite thing to do. And when you guys are answering your math problems, might as well be polite about it, right? So, variable with the highest power, then variable with the next highest, so on and so forth, until your last one is your constant. Okay, so we're going to go through one more example, and this last example, we're going to make it a bit spicier. So let's move on to problem number 3. Okay, we have arrived to problem 3. So if we look over here, once again, I promised to make it a bit spicier, and I did. Not only is this parenthesis longer, now there's 3 separate terms in it. We have 2 different variables, right? We have x and we have y. And I took this problem and I made it so difficult because I want to show you guys that this generic rectangle method works for all distributive property problems. No matter how gross they get, how many things we want, the rectangles are flexible. So let's start with this one. I'm going to draw a big rectangle over here because this one's a bit bigger, right? All right, got my big rectangle. Now, I'm going to write 3x minus 4 as my height. And then minus, don't forget to bring those signs over, minus 4. So I'm going to label this for you. This was the height. And then this one is going to be the base. One thing I haven't mentioned yet is it does not matter which part you choose as the height and which part you choose as the base. Either one can be interchangeable. I usually notice like, oh, my height is a bit shorter, so I'm going to choose the shorter one for the height. Something as simple as that. Okay, now I have my rectangle partly set up. I'm going to check my base here. Here I have a sign that separates them, so let's draw a line. Here I have a sign that separates these two, so I'm going to draw a line. Okay, now I don't have any more, so let's move on to our height. I only have one sign, which is right here, and then I'm going to draw a line. And if you look, bam, we got a generic rectangle set up. Okay, looks wonderful, doesn't it? So let's go ahead and solve this thing. Once again, we're going to go to each individual little rectangle and do the base times the height. So we got x times 3x. So x times 3x is 3x squared. X times negative 4 is negative 4x. And then we got 3x times y, which is 3xy. Y times negative 4, negative 4y. 3x times negative 7, so negative 21x. And negative 7 times negative 4, positive 28. Now that I have all my different sections filled in, I'm going to take it, bring it out, and rewrite it as a sum. So we got 3x squared, because that's my highest power variable, so I'm going to write it first. Plus, let's see, negative 4x plus negative 4y plus 3xy minus 21x plus 28. Whew, man, talk about a long string of numbers, right? If you have a problem like this where it's just super long, you just got a million things, be careful when you're combining like terms. Make sure you double check, okay? So if we look here, we got a y, we got an xy, those don't combine. X squared, that doesn't have any like terms. Oh, if we look here, I have a negative 4x and a negative 21x. So I can combine like terms there. So I got 3x squared, and let's combine these two. Minus 25x is negative 4x minus 21x is equal to negative 25x. And then I have my minus 4y and my plus 3xy plus 28. And I have no more terms that I can combine, so I am done right there. Okay? It's so flexible, isn't it? It's so flexible, it's wonderful. We can use it for all types of problems, and we can adjust to our needs. All right, we're gonna go over one last problem, just really quick. It's gonna be another shorter one like problem 2, but there's something I wanna show you guys and a way to check your answer. So let's clear off the board and let's move on to problem number 4. Okay, here we have problem 4. We've kind of regressed a little bit in the spiciness levels, but once again, I just wanna do this last one to show you guys a way to check your work. I would pause the video here and I would solve it yourself first, see if you get the same answer as me. Okay, with that being said, I'm going to work through it now. Okay, let's see, draw our rectangle. And on the bottom, I'm going to do x plus 2 as the base. And for the height, believe it or not, I'm going to do x plus 2. Now I have my base and my height set up. We need to separate this rectangle out. Here I have a plus sign separating these two parts, so I'm going to draw a line. Plus sign separating these two parts, so I'm going to draw a line. Now I'm going to multiply the base by the heights to find the area of this. So I'm going to do x times x, which is x squared, x times 2x, which is 2x, x times 2, which is 2x, and 2 times 2, which is 4. Okay? I have all of my areas filled in, so let me now take it out and rewrite it as a sum. So I'm going to do x squared plus 2x plus 2x plus 4. Now let's check, do we have any terms that we can combine? We do, we have a 2x and we have a 2x here. So I'm going to write x squared, and let's combine these two, which becomes 4x. So x squared plus 4x plus 4. And that's it, I'm done. There's no more terms I can combine. That's my final answer. Okay, now let's say that you get to this final answer and you're confident, but you're not sure. You're like, I think I did it right. Well, what you can do is you can come back up to our generic rectangle and you can do this wonderful little trick. You can take your generic rectangle and you can you can take the area on the inside and multiply diagonally. Multiply diagonally. And write the answers that you get on the outside and you can check them. 2x times 2x is, here I'm going to write it in greener, 4x squared. Okay, x squared times 4 is 4x squared. Huh, that's a little strange, isn't it? They're the exact same. And that's a way you can check your answers. You can do this little cross multiplication idea, multiply diagonally, and if you get the same answer coming out for both of them, for here, notice we have the 4x squared and the 4x squared, we know we did it right. If you get the same answer, you know you did it right. And it's a fantastic way to check your work just super quick. I got these, so I know I did it correctly. Come down here and I can rewrite it out and combine my like terms. Okay, with that being said, we're going to end it off here. The generic rectangles, please try and get good with them. Just look up some distributive property problems and practice it, because I will be using it in later videos and it is such a fantastic tool to have in your toolbox. Okay, with that being said, if you are using my channel to learn some math, maybe consider checking out some of the playlists. If you just need some more help, once again, maybe check out some of my suggested videos at the end of this video. Otherwise, thank you guys so much for coming to class today, and I hope to see you guys in the next lesson.